right, we are on module 3. We're going to start with topic 1, solving linear equations. So on number 1 it says solve for x, and here we have 1.2x plus 3.6 equals 4.8x. Now for a lot of us, this is going to make us reach instantly for the calculator because we have decimals, but remember something you can do is you can always kind of like upgrade everything by multiplying by 10. And this is okay because we're doing the same thing to both sides, so it keeps both sides of the equal sign balanced. So now we can work through this problem without the scary decimals. So I need to get the x's to one side, so I can either move the 48 over here or the 12 over here. I'm going to decide to move the 12 over because, for one, by moving the smaller one to the bigger one is going to keep it positive, but also that way I won't have to move the 36 later. So I'm going to subtract the 12x because it's positive to remove it from both sides. So here I'm getting that 36 is equal to 36x. Now some of you can see instantly what it is, but if I want to follow through, I would divide both sides by 36. So whatever 36 divided by 36 is x, and of course that's 1. And some of you saw that back here because 36 is what times 1 is to get to 36. Alright, number 2, very similar. X equals 26 minus x. I need to move the x's to one side. Now some of you are going to want to instantly jump that this might be a special thing because you're seeing like, ooh, there's x's on both sides. But sometimes it's good just to follow through because not everything's always going to cancel out. So let's see what happens. If I want to move this negative x over, I would add it. Oh, and now I can see it's not going to cancel out. I'm actually going to end up with 2x is 26. Okay, so 2 times something is 26, so x is 13. All right, 3, is there one solution, no solution, or infinite solutions? So what's kind of nice about, instead of it asking for the solution, we just need to figure out which one of those categories it's in. So we only need to solve so far as to see if things are canceling out, if it's a true statement or not a true statement. So we're going to start by distributive property. So anything outside of parentheses, you multiply by everything on the inside. And when you have a negative out front, it means there's a negative 1. So basically when I distribute, I'm unpacking all of those parentheses, and now I just have it all laid out. And I can start combining like terms. So things on the same side of the equal sign I can put together. So if I'm looking on this left side, I have 6x minus x, so total over here I have 5 x's. And then I have 8 and another 8, so that's 16. On this right side, 12x's minus 7x's, so that's 5. 6 plus 10 is 16. Ooh, interesting. So I'm noticing I have the same thing on both sides. So whenever you start noticing that, like we could keep going through and you would just have the x's cancel out equaling something that's true. Or you can stop to think like, anything that I put in here is gonna equal the other side because of course you have the same actions happening on both sides. So because anything will work, this is an infinite solutions. All right, number 4, same thing. We're looking to see what type of solution it is. So I'm going to distribute out my parentheses, so I just have that 3. And then combine like terms on each side. So I have a 3x minus x, so I have 2 x's over here. 3 plus 4 is 7. Okay, so I do have the same x's on both sides, which means they'll cancel out. It's kind of like just taking the same amount of weight off each side of a scale, and I'm left with 7 equals negative 6. So that isn't true, right? So that means there's literally nothing I can put in for x that will make this true. So this is a no solution. Okay, number 5. We're still solving for x, it's just kind of going up in how complex it can be. So here I have 6 times 2x minus 1 over 5, and that all equals a negative 18. So there's a couple things we could do. We could distribute out that 6, kind of see what we have and divide each of those terms by 5, or we could actually just simplify everything by multiplying everything by 5. I'm gonna hold off multiplying everything by 5 right now just because I can see looking ahead that may not be that helpful. Yeah, let's go ahead and do it. Okay, so let's see what happens. Sometimes like when you do these shortcuts you end up with like really big numbers, so let's see how bad it is. So if I multiply both sides by 5, on this left-hand side, it's just canceling out that 5. So I have 6, 2x minus 1. But on this other side, I need negative 18 times 5. So let's see what that is. That's a negative 90. Okay, so not that bad. So now let's just progress like normal, distribute out that 6. Now, something to remember with distributive property is keeping the signs correct. So positive times positive is positive, positive times negative is negative. Because if you mess that up, then everything else is messed up. I want to get rid of the subtracting 6 by adding it to both sides. And I'm going to move that work over here so we have room. So I still have the 12x. And on the other side, a negative 90 plus a positive 6, it's like I was $90 in debt. I fined $6, now I'm only $84 in debt. And my last step is to divide both sides by 12 because I want to undo the multiplication that was happening. So I just need to figure out 84 divided by 12, which is 7. So it's a negative 7. Remember, you can always also check your answer by taking what you got, putting it back in, and making sure it works. So that negative 7 times 2 minus 1 times 6 divided by 5 is negative 18. All right, here on 6, actually now that I'm looking at it, maybe it would help to multiply everything by 3 because I noticed that would get rid of this grossness and it would get rid of this grossness right here. So let's go ahead and see what happens when I multiply everything by 3. So for this term right here, because the whole thing is divided by 3, it's going to cancel out that 3 that's at the bottom because you end up with 3 over 3, which is 1. For this term in the middle, basically we're just kind of upgrading what everything's going to multiply by. So instead of times negative 3, we can do times negative 9. And then for this 7 over 3, the 3's are canceling out because they turn into 1. 3 over 3 is 1, and that's just a negative 7. So it kind of really just helps simplify everything. So now I can distribute out this negative 2 and this negative 9. Now what I want to do is I want to combine like terms and I want to move the x's to one side. So I can kind of be doing multiple things at once. So for one thing, I want to move the 27 to the left hand side because this is negative, so moving it over will make it positive. So adding 27x. I can also combine these two when I do this. So here I have 17x, I still have a minus 8, and then combining these two over here, the negative 18, the minusing 7, in total that's a negative 25. So now, like, it's a little bit simpler. Now we just have 2 steps left. So now I need to add 8 to both sides. So I'm left with, sorry, there's not much room. So I have 17x equals a negative 17. So what times 17 is a negative 17? That's a negative 1. All right, moving on to topic 2. Now we're looking at systems, which is a collection of equations. And the solution to the system is the number set, the x and y, that works in both equations. Now when we look at a graph, what that represents on the graph is going to be where they cross, because you remember that if I look at a line, every single point along this line is a solution to that equation. So the reason why where they cross is the solution to the system is because it's the number that works in both of them, because it falls on both lines. So for here, and this is when we solve by graphing, we can just see, oh, it crosses at 3, 2. And that would be it. For number 2, we're going to solve it algebraically. I mean, you can always graph them to double check that that's where it crosses. So Desmos is great for that. So we've learned a couple different ways of doing it. We can either do substitution or elimination. And this one's actually set up for both. I could take this 2x minus 4 and put it in for this y, set them equal to each other, and then solve for x. Or I can do elimination because they are all nicely lined up. I prefer elimination, so I'm just going to go forward with that. It doesn't matter which way you solve it, you should still get the same answer. So if I'm going to do elimination, I'm going to do y minus y, that way they cancel out. So once you decide if it's addition or subtraction, you're doing that across all of them. So for each column, you're just subtracting everything from itself. So y minus y, it's not that it's just nothing, that's a 0. 2x minus negative x, so that's going to be 3x. And negative 4 minus 5 is a negative 9. So now I use this to solve for x. So I'm going to add 9 to both sides. So now that I have something over here, so 9 is equal to 3x. So x is going to be 3 because 3 times 3 will be 9. So that tells me that where these two cross, the x is 3. So I have half of my answer. So now I'm going to take this, the fact that x is 3, and I can put it back into either equation. So maybe I put it into the second one because x is already a little simplified, and that would look like this. So all I did was I just put the 3 in for the x, and now I can see, well, negative 3 plus 5 is a positive 2. So my full answer, and you will want to leave it in point form, is 3, 2. So these two, if I were to graph them, they cross up 3, 2. So actually exactly like this. Number 3, we're going to do pretty much the same thing. Now, they're all lined up for elimination, but they're not the right numbers yet, right? Like you need something that's going to cancel out. So what we can do is we can multiply everything or divide everything by something so that we have something in common. So maybe I'm looking at the y's. I have a 2y and a 1y. So I'm going to multiply everything for the second equation by 2 to get me something similar. And if I want, I could do negative 2 if you really want them to be exactly the same. Either way, it doesn't really matter. So I'm going to be changing the second equation into being negative 3x plus 2y equals 10. Okay, I'm noticing I'm seeing a lot of similar numbers, so this might be a special one. So let's see. I'm going to move this top equation right below it just so it's easier to work with. Okay, so here's the same system. It's just same equations, just kind of like increased. But still proportional. So I'm going to be adding, if I want a 2y to eliminate with a negative 2y, I need to add everything. So I'm going to add the x's together, the y's together, and the 10's together. A negative 3 plus a positive 3 is 0. A positive 2 plus a negative 2 is 0. So now we're already noticing something's happening. Everything's canceling out. 10 plus 10 is 20. So basically we have 0 equals 20, which is not true. So because we have something that's not true, we know this is one of our special ones. This is a no solution. So what that means here is because it's a no solution, these lines are parallel to each other. So they literally are never going to cross. So that's why no set of numbers is going to work for both of them because they're never going to touch each other. Let's try with 4. Let's see, let's just do substitution this time because we haven't done it yet. So y is defined as 3x plus 1 in the first one, so I'm going to input that into the y for the second one. So now I just solve for x. Well, I'm noticing there's 3 x's on both sides, so I can cancel them out, like taking the same amount of weight off each side of a scale. And I have 1 equals negative 6. Oh, that's also not true. So this is also a no solution. And you could actually tell that from looking at the equations. They have the same slope, which means they're parallel lines. Now, don't just see that they're parallel lines and don't just notice that they have the same slope and automatically assume it's a no solution, because if these are the exact same equations, then they will have the same slope, but then everything's the same, and then it's infinite solution because it's the same line. So don't work too fast on those. All right, number 5, admission to a museum costs $12 for adults, $7 for children. A group of 35 are attending the museum, paid a total of $315. So we need to write a system. So the two different equations we're going to write is one based on the number of people and one based on the amount of money, essentially. So if I want to start with money, 12 for adults, 7 for children, and they paid $315. If I want to do then the next equation for the number of people, the amount of adults plus the number of children was 35. So there's my system. And of course, if you want to graph these, then just change A to X, C to Y. So now we're going to solve this. Now, we can either do elimination, so I would probably want to multiply the entire second equation by something, or I can do substitution where I would want to move one of these over. Or you could just throw these into Desmos and see where they cross. Let's see. I'm most comfortable with elimination, so how about we do that? So we're going to need to multiply this entire second one, maybe by 7, just so we can eliminate the children first. So that would be, we still have the first equation, and everything for the second equation is going to be multiplied by 7. So I need to know what 35 times 7 is. That's 245. Because these are the same sign, I'm going to subtract. So 12 A's minus 7 A's, that's going to be 5 A's. The 7 children cancel out with the 7 children. And 315 minus 245 is 70. So if I do 70 divided by 5, that's going to be 14. So this tells me there's 14 adults. Okay, but I'm not done yet. I need to find out how many children there are. Well, I mean, if you know that there's 14 adults, 35 people total, we just need to do 35 minus that 14, and the children will be 21. So, of course, it's really easy to get these like A equals 14 and C equals 21. What it means in terms of the context is bringing it back into what it is that we're talking about. So basically we're just solving, well, how many children, how many adults. So that's why this answer really is different than just this. It makes you, it's saying that you understood what you were actually solving for. All right, number 6. June has 4 times as many blue marbles as green marbles. She has a total of 35 marbles. Write the system. Okay, so we have a couple things happening. One, we know she has 35 marbles, so blue plus green is 35. That's simple enough. But then we have this 4 times as many blue marbles as green marbles. Okay, so she has 4 times as many blue, so there's way more blue. So you have to multiply green by 4 to get to the blue. So 4 times green is blue. There we go. That's our second equation. So now I'm going to solve it, and this one's definitely set up for substitution because we have a variable isolated. So I'm going to take this 4G and I put it in for B. So now once I solve for G, I'll know how many green marbles there are. So I have 5G equals 35. Well, 35 divided by 5 is 7. So for G, there's 7. So in terms of the context, I have 7 green marbles. Okay. Then I use that to find out the blue. And I can either do the 7 times 4, or I can do the 35 minus 7, kind of either way. And I'm getting that there's 28 blue. And that's it.